Welcome to the Southern IPM Hour. We are the Southern IPM Center. We do these webinars once a month at least to present research, issues, and programs in integrated pest management from the Southern region, and sometimes nationally, like this one, through this webinar series. And it usually takes place at least one Wednesday per month at 1 p.m. Eastern. I'm Kayla Watson. I'm the Communication Director for the Southern IPM Center, and we are housed at two different universities, so at NC State and UGA. We have a mission to coordinate IPM across the region, and we are also one of 4 regional IPM centers supported by the USDA NIFA Crop Protection and Pest Management Regional Coordination Program. If you have questions today throughout the webinar, please feel free to ask those at any time. And if you can, ask those in the Q&A box. It's a little bit different from the chat. And Peter and Ariel are going to do their best to answer those as we go throughout. But if there is a question that needs to wait to the end to kind of have more discussion around, we can answer those at the end as well. So feel free to put those in the Q&A at any time. And we do have 2 speakers today from the IPM Institute. We have Peter Werts, who's a Senior Project Manager for Specialty Crops Programs, and Ariel Larson, who's a Senior Project Manager of the Sustainable Food Group. So they're going to be speaking with us about the Pesticide Risk Tool. So welcome to you both, and looking forward to the presentation.
Great. Thanks, Kayla. Thanks, everyone, for coming. Like Kayla said, I'm Ariel Larson. I'm a Senior Project Manager at the Sustainable Food Group. We are a branch of the IPM Institute of North America, based in Madison, Wisconsin. We have our organization specializes in improving adoption of sustainable agricultural practices, such as integrated pest management, by working with food companies, food supply chains, growers, packers, shippers, all the way up to large food retailers. And today we're going to talk about a tool that our organization developed in collaboration with scientists called the Pesticide Risk Tool. Without further ado, I will get going. So today we're going to cover an introduction to the Pesticide Risk Tool. Basically, what is it? What does it do? What do the risk results look like, and how to understand the risk results? And then talk more about how the Pesticide Risk Tool is being used currently in various populations of grower groups, and cover a little bit just about the benefits, advantages, and challenges of using a tool like this. So after this webinar, we hope that you'll understand how to use the Pesticide Risk Tool to identify risks in a supply chain. And supply chain could also mean just like a group of growers, some sort of grower population where you are using the tool. How to quantify risk and track changes over time, and how to communicate risk reduction. I am certainly not sharing any new information with this group when I say that pesticides are important tools in many modern farming systems, and that pesticide use carries a variety of risks associated with it, and those risks need to be carefully managed. And of course, this is a part of an integrated pest management program, the ability to, when pesticides are needed to manage a pest, being able to compare risks and select and prioritize lower risk options as part of that IPM program. And so the Pesticide Risk Tool is designed to evaluate risk associated with pesticide use in agriculture, specifically using the best available science, and it can be used as part of an integrated pest management program in that way. And I will start off by defining risk, because it's in the name, Pesticide Risk Tool. It's a core concept here, and so that we are all having a shared understanding here. When we say pesticide risk, risk is a function of both toxicity and exposure. So toxicity meaning what are the physical chemical properties of a pesticide active ingredient that really defines the risk or the hazard, and that's the type of information that's found on pesticide safety data sheets, pesticide labels. Many prohibited pesticide lists that are part of certification programs are hazard-based lists. And hazard is really distinct from risk in that risk also factors in the potential for exposure. So not only how, for example, how toxic is a chemical to pollinators, but what is the potential that pollinators are actually exposed to that chemical? So the combination of those two things is the risk of a pesticide. And that's what the Pesticide Risk Tool is looking at. So it's a web-based tool, it's online, pesticiderisk.org, and it evaluates risk to 15 different risk indices. And those include, I'll show them on a later slide, but they cover human risk indices, environmental risks, and then pollinator risks specifically. And they are mostly acute indices, but there's a couple chronic risk indices as well. There are various ways to use the tool. It can be used by individuals, maybe a farm manager or grower, to manage their decision-making around pesticide use. And then it's also used in various sustainability standards and certification programs. And it's been used by food companies in their supply chains to assess risks as well. So there's a variety of user groups of the tool, and it can sort of be customized in terms of how you want to interpret and use the results. One way that it can be used to track, quantify, and track risk over time is by using the results to make sort of a pesticide risk metric that you can use to track risks. And then again, decision support. So like comparing different pesticide application scenarios to try to identify lower risk scenarios. The visual on the right here is basically a snapshot of a comparison of just two products and looking just at the environmental risk indices. So this is what the interface looks like after you put in information. It basically shows these quantitative risk results for 15 different indices, which can be viewed in the chart form or downloaded in a spreadsheet if you're looking at more than a couple. And risks are basically categorized as low, moderate, or high, or sometimes no data. So the risk results are adjusted in the models based on factors like the application rate, application method, timing of the application, and then some optional inputs like restricted entry interval or whether or not gloves are being worn as workers re-enter after the re-entry period. Really the primary driver is the active ingredient itself in the product. The risk results account for pesticide toxicity to different species. So for example, like there's an avian acute index. It's not looking at a single bird species, but rather a population of different species and sort of accounting for that whole species distribution. And where data exists, it does consider known field level impacts of pesticide applications. So those are sort of the basics. I'll get a little bit more into the different specific 15 risk indices, as well as what the different risk scores represent. That's covered on a later slide, so I'm going to skip ahead. These are the 15 risk indices. Environmental risks, several aquatic ones, looking at aquatic algae, aquatic invertebrates, fish, birds, both acute and reproductive or chronic, earthworms, and small mammals. Earthworms sort of being a rough proxy for like soil organisms as well. Human bystander risk, the three indices are inhalation, so inhalation risk, dermal risk to workers, and cancer risk to workers via dermal exposure, that being a chronic index. 2 consumer dietary indices, so the related to residues on food crops based on pesticide use, and then 3 pollinator indices. And so in order to sort of without going into the super depths of the white paper on each of the 15 indices here, I'm going to talk a little bit more about the models and the science behind the pollinator indices. That will sort of help give an understanding of what the different indices look like behind the scenes. So the pollinator indices, again, there are 3 sub-indices here. There's looking at risk to pollinators when a crop is in bloom. So being a pesticide application when a crop is in bloom, pesticide applications when the crop is not in bloom, and then off-crop risk, which is basically like risk to pollinators in the area around the cropping system, but not directly in that cropping system. So essentially drift. And it's looking at risk to wild or managed pollinators. And each of the different groups of indices, human, environmental, and pollinator, have a slightly different, or have a completely different, basically a scale. So what is the x-axis? So in pollinators, the scores, or the risk scores, which is the output of the tool, are scaled such that scores less than 1 are considered low, scores 1 to 10 are moderate, and scores greater than 10 are high. And this index is actually also on a logarithmic scaling. This is to illustrate how both toxicity and exposure now are accounted for in the pollinator risk index. So toxicity, the models are looking at both oral and acute pollinator toxicity. So looking at LD50 or lethal dose 50 data to inform the risk output. So in this is showing data from the white paper looking at 3 different species of bees, their LD50s, and then this is also illustrating sort of how multiple bee species are being considered in this index. So it's accounting for the LD50s. And then, again, that's the toxicity part of it. Risk is also considering exposure. And so what the exposure part of the model looks at is basically a hypothetical sort of composite honeybee behavior. So how are bees foraging, and how are those foraging bees likely to be exposed? And then consumption of pollen by nurse bees. So it's considering both of those bee behaviors in modeling how bees are going to potentially be exposed to a pesticide application. And so it's looking at different potential exposure routes based on application methods and considering spray drift, dust applications, air blast versus spray boom application method. And basically how much of a lethal dose is this hypothetical bee species likely to be consuming in the course of a day of its normal bee behavior. What the indices are not doing is looking at sublethal effects or chronic effects, which are both obviously sort of important factors as well, and incredibly complex. And so the modeling at this point in time is focused on acute exposure risk. There's just more extensive data available on that type of risk.
Ariel, I think this would be a good time to explain that basically all of our PRT indices are really looking at where we can have a predictable dose response, right? So when we look at LD50 data, as the old saying goes, you know, dose makes the toxicity. You can drink enough water to kill you. So across all of these indices, we're looking at where is there the ability to have a predictable dose response based on that application rate of the product. And so that's why we can't account for sublethal effects. But then in like the human indices and some of these other indices, it's why we can't predict risk to a pesticide that's like a cholinesterase inhibitor or a developmental or reproductive toxin, or endocrine disruptors. So, and I don't know if we have more on that in the other slides, but I wanted to mention that now.
No, that's a good place, because I don't think we do. Okay, so I won't go as in depth, but will overview sort of what the other 15 indices are. So the environmental indices are, again, avian, acute and chronic, earthworms, small mammals, and then 3 different aquatic species. And the environmental indices are scaled from 0 to 1 because the scores represent the probability of an adverse effect. And there's explanations on the website basically of like exactly what that adverse effect is for each of the indices. And then the scores from 0 to 1, when we're looking at up to 0.1, that's considered low risk. That's really sort of within the margin of error of the models. 0.1 to 0.5 moderate risk, and 0.5 to 1 high risk. And especially when you're looking at like a high risk result, that's where you're thinking about risk mitigation strategies and what can I do to mitigate this risk. So environmental indices are a probability score. The human bystander indices scores are ratios. So on the charts, they're displayed from 0 to 2, but really can go greater than 2 because they're a ratio. Scores greater than 1 are considered high risk because those are what represents a predicted exposure to that chemical that exceeds some sort of safety threshold. And typically that's an EPA safety threshold. What's the threshold of no harm that's assumed? So greater than 1 is saying there's an exposure to a concentration that is greater than that threshold. Below 1 in the 0.5 to 1 range would be moderate, and then less than 0.5 would be considered low risk. And these indices are human risk indices, so it's looking at risk to workers, but also bystanders. So any other humans that are in and around where pesticides are being applied. So it could be like workers in an office or workers working in a nearby field that are harvesting, a harvest crew, community, homes in a community that might be nearby, worker housing, that type of risk. And then consumer dietary indices, there are 2 indices here. There's an acute and a chronic, and they're basically looking at risk of the consumption of a pesticide residue compared to a safety threshold, or what the EPA tolerance is in terms of what's considered a safe amount to be on a food and consumed on a food. And the acute one, unlike the other indices here, is really strictly based on the USDA pesticide data program testing and residue results. So unlike the others, it's not influenced by application method or even application rate. It's influenced by what's actually being found on that food when the USDA does this extensive testing of thousands of samples annually, and looking at residue risk in that way. Risk categories, this one is scaled from anything above 1 is considered a high risk in these cases. This is just to summarize sort of that pesticide risk tool was developed based on the best available science in collaboration with scientists that have expertise in the respective risk index areas. So our collaborators are Dr. Pierre Minot on the environmental and pollinator risk indices, Dr. Susan Kegley on the worker and bystander risk indices, and then Dr. Charles Benbrook on the dietary risk indices. And there are peer-reviewed papers on each of these indices that are available on the website without the need to log in or anything. The PRT uses a variety of data sources. So US EPA databases, USDA pesticide data program, which is the residue testing, and then also some European pesticide toxicity databases, and some California-based databases as well. And that's just based on what the scientists felt like was the best database to be incorporated into their risk models at the time that the models were developed. Pesticide Risk Tool was developed in the US and does the pesticide product database is based on what is US EPA registered. However, there is the capacity to look at pesticides that are not registered in the US or that are registered in other countries internationally by basically requiring some additional input from the user that describes that product in more detail. So things that we're typically getting from the EPA, like is the product a solid or a liquid, becomes something that the user has to input. So it requires a little bit more work to use, but it can look at products that don't have an EPA registration number in that way as well. So that sort of concludes the first part on the description of the tool itself, and then we'll spend the next like 15 to 20 minutes talking through various use scenarios and really illustrating the potential to use this tool to do a variety of things. So are there any, maybe I'll pause just for questions at this point if there are any.
I'm not seeing any in the chat, Ariel, but this is a good time to remind everybody that if they do have questions, they can put those. Well, there is one in the Q&A now. Okay, there is one, Ariel, and it says, regarding workers, does the system distinguish between applicators and other field workers?
Right, so this is not looking at applicators and pesticide handlers following all the required and appropriate PPE to their position responsibilities. This is really looking at field worker bystanders. So, you know, if you could be in the Central Valley of California where, you know, in one field people are harvesting cilantro, and then there could be a gravel drive row, and in the next field they could be, you know, spraying lettuce with an insecticide. And if there was a drift event and those farm workers had pesticide inhalation, what would that risk be to them? So and as far as how much it costs, it's based on a sliding scale based on the size of a farming operation. And I think later we may be able to talk a little bit more about you know, how we use it as we use it in these programs with grower groups. You know, we do some bulk rate pricing on it, and then we also have some researchers that are using it, and we've looked at creating kind of a like a researcher fee schedule, because we know they're interacting with it differently than how like a grower may.
And no, unfortunately, we don't have any API capacity at this point.
Yeah. So the question was, is the data available in an API? And apparently not yet. Okay.
So,
Right.
Ariel, would you like me to present these next suite of slides up
Yeah, go
to
for
like
it.
up to? I can take us up through the LODI, or like right before the LODI rules.
Yeah,
So
sounds good.
so I've been working a lot with the PRT tool over the last 10 years with a couple of different grower groups and trying to come up with the best ways to present this data in a way that it resonates with the growers. So there's a couple of certification programs that we run here at the IPM Institute. One of them is called Eco-Apple, and a lot of these slides are showing grower data from that program, and then also just ways that we have evaluated pesticides and then presented it back to the growers to see what they think. One of the things that we've started to look at is really focusing in on the number of high risks totals. So if we think about this, there are 15 indices. So potentially each pesticide application, worst case scenario, could have 15 high risk scores per application. So one of the things that we're saying is, okay, we really don't need to be concerned about low risks. Moderate risks, we should keep our eye on them. And it's really the high risks that we want to try to identify and resolve. One of the things that we have found to be very effective is to anonymously present the grower data back to the growers. They know what letter they are on that chart, and it really gets people asking this question, well, what is grower like D, E, and F doing to produce a successful commercial quality crop without generating much risk? And then what is growers G, H, and I doing that they are creating so much risk? And so we found this to be an effective approach to anonymously share data with a group of growers and kind of get a conversation going around the pest management practices they're using and the actual pesticides that they feel they need to use or successes with alternatives. It really kind of gets their thinking going. Next slide, please.
Just one more comment here too.
Yeah.
This is also something that can be done in one growing season. So a lot of the other ones that Peter will talk about are sort of over time, but this can actually be done just with like 1 year of data, which I think is a benefit to being able to look at this data in this way.
Okay, next slide. So the other thing is with the outputs that we get, we have a bulk uploader where you can take an entire spreadsheet of spray records. You could have multiple grower records in that spreadsheet. And when you get the results, we can do other things with our results, like sorting everything out by insecticide, fungicide, and herbicide use. And we can start to understand, okay, well, what's driving risk in our spray program? Is it the insecticides, the fungicides, the herbicides? And then the other method that we've started to look at is the average number of high risks per application on a particular farm. And this is because when we plotted out total high risks over time, we get a lot of noise. Because there's a lot of variability in one season and between seasons. If we had a particularly large crop, a grower may be more inclined to spend extra money on pesticides and maybe apply more pesticides that season. And if it's a light crop, the growers may be wanting to pull back on applications, or we've seen instances where it's a light crop, so the grower wants to protect what they have at all costs. We have large farms, we have small farms. It's like we have such variability across a grower group. How do we compare risk to a 10-acre apple orchard next to a 100-acre apple orchard? And so what we found is this approach of coming up with the average number of high risks per application for each grower, or for the group of growers over that particular season, that starts to give us something that we can compare over time. And so this is an example of looking at grower data over a 4-year period, and we can really see how these risk profiles have changed for each year for our different types of pesticides. So we'll get to Matt Bauer's question in a minute, because I think there are some additional slides here where that would be good to share. So identifying high-risk products, one of the ways that we're communicating some of this to the growers is to provide a list of the pesticides that we feel are generating the greatest amount of risk. We've color-coded it in a slide deck like this, where our red squares represent high risk, kind of the brown to orange is moderate, and then the yellow is low. And as we can see, you know, products like the organophosphates, like Fosmet. I know azine phosmethyl has been gone for over 10 years now, but it's still a great example to show. A lot of growers are familiar with that. And then some of the neonicotinoids like imidacloprid is a good example. We can really hone in on, you know, the total number of risks that are being generated and to what indice. And then we can also start to look at alternatives that generate less risk. So if we go to the next slide, we can present alternatives and where some of those risks still exist or have been mitigated. One issue that we run into is, you know, our tool is not perfect. You know, in this case, this data is with apples. We have over 1,100 registered formulated products on apples, and there's a lot of newer, some newer biopesticides coming out onto the market, as well as some newer reduced risk insecticides, and we don't necessarily have the data for everything right now. So you can see, for example, Savanto does not have any data for these other indices. We only have partial data on it. But we can really see how, as we present alternatives to the growers, we can show where those risks go away. Next slide. So let's see here. So with the Pollinator Index, this is an example of really then focusing in on, you know, which active ingredients in this group of growers were driving high and moderate risks. And again, looking at the average number of risks per application. And in this data set, you know, it's the neonicotinoids, Fosmet, which is an organophosphate, carbaryl, and methylcarbamate that are driving our high risks. And then when we look at moderate risks, we see that carbaryl shows up there again. And this really shows where PRT has the ability to really differentiate risk based on, you know, the actual amount of active ingredient being applied. A lot of our products, right, there's really only one active, or there's only one rate, or it's a fairly narrow rate range. But if we look at some of the older pesticides that have been around a while, some of them do have a really wide rate range, and carbaryl is one of those products that as we change the rate, we really quickly see differences in those risk scores to pollinators. Next slide. So this is also with EcoApple, looking at the total number of high risk scores over time. And you can see kind of this variability, you know, kind of down and then up and then down and then up. And best way that I've been able to account for that is just some variability in the crop load over the season and kind of what's driving some of the pesticide use decisions. The important things about this data is 2003, 4, and 5. This is when the growers were still using synthetic pyrethroids and organophosphates. 2006, the growers eliminated use of organophosphates and pyrethroids from their spray programs, and it has been a steady decline in risk over those next few years.
And Peter, this may be a good time to answer Deborah's question. I mean, it really depends on like the user group and how involved we are with that group. So like Peter with EcoApple, like, yes, he would definitely have a sense of like the pest management factors driving the change in risk. If we're working with a company and their growers are not collecting information on target pest, then it would be a lot harder for us to draw any conclusions about like what was driving changes in risk. So it just depends on the quality of the pesticide application records that are available, and like, I guess how good our relationship is with that organization. Like with EcoApple, it's like that's a long-term program that we've been working on. We have Peter has a really deep understanding of like what those growers are facing in terms of pest pressure year in and year out. And so we can look at EcoApple data and have that understanding. Whereas if it was, a client that we weren't as close with and they didn't really know what pest pressure growers were facing, they just had some records without target pest listed, then it would be harder to say.
And Ariel, would you mind to read that question out loud? Only the panelists can see those until we.
Okay, sorry. Yeah. Oh, good point. Yeah, Deb was asking, when we look at average high risks, do we have any data on what pest is driving those applications? Perhaps a new invasive pest. So I was speaking to that question in terms of like, do we know what pest factors are driving trends or driving the data results that we're seeing?
And Matt's question, where are you getting the pesticide usage data as input for the calculator? Are producers using the tool as part of a commodity group program? So the answer is yes. This is all data that growers have voluntarily given to us or have been given to us as part of their participation in a program. And one of the challenges we have is, it's really hard to make these comparisons between like a conventional low-level IPM program versus a advanced biointensive IPM program, because there aren't these really large, databases. I mean, California has pesticide data reporting, and you can look up pesticide data from California, but for the most part, this is grower submitted data from growers that are participating in a more advanced biointensive IPM program. And when it comes to apples, every grower is going to tell you they're doing IPM. So this slide, this kind of starts to now take us to, well, how do we talk about this in the marketplace and, kind of speak to the accomplishments of the growers? We can see here over time how we've reduced our average high risks per application over a large period of time. And again, here, 2004 to 5 and 6, that's as we phased out the OPs and pyrethroids. The other thing that's important to understand here is we have to kind of put some context behind these applications, meaning we may get a bunch of scores that are indicating high risks to pollinators, but none of those applications were actually made while the crop was in bloom. So a crop like apples with a determinate bloom period, a very defined and shortened bloom period, the late summer sprays of a neonicotinoid, were not applied during bloom. So we have to manually remove some of those results. Now, if you're looking at a crop with an indeterminate bloom, it has bloom all season long, cucumbers, for example, then those in bloom scores could be very, very real to pollinator risk. Next slide. So another thing that we did is we looked, and again, this is with our Eco-Apple program, which has a restricted pesticide list that's more stringent than what EPA allows. So again, none of these growers are applying OPs or pyrethroids. And we looked at a group of growers that joined the program a little later, more like between 2009 and 2008 and 18. And one of the things we asked them to do was to provide their spray records in the years before they participated in this IPM program. And so what we found is, a lot of these growers had minimal use of OPs and pyrethroids, and we still made further reductions in risk through their participation in our certification program. And so this is just kind of another way to show the data. And to me, what this really shows is the benefit of grower groups kind of being engaged in a community of practice or a learning community where the growers are sharing ideas with each other about advanced IPM strategies and how they can have the most successful IPM program. And what we find is that regardless of what kind of calendar year the grower joined our Eco-Apple program, that over a 5-year period, they were able to make further reductions in pesticide risk through their participation in an advanced IPM program. Next slide. So really, we should have started with this slide, but Eco-Apple has been around since 2004. It's mostly focused in the Northeast, New England, United States. It is a third-party certification offered to these growers by the IPM Institute. We have about 16 growers participating in the program. And what we have is a suite of kind of minimum IPM practices that they have to follow, as well as advanced IPM practices that they can kind of choose and pick, what's the best fit for their farm. And then our pesticide use restrictions. And we've used the Pesticide Risk Tool to then inform what pesticides are allowed on our list of approved pesticides. So Ariel's going to talk about 2 more programs, and I'll pass it over back to her.
Thanks. And yeah, this gets to your question earlier, Matt. These are sort of the grower groups that are using the Pesticide Risk Tool. And yes, we probably could have put this up sooner. LODI Rules is a certification program for sustainable wine grape production out in the LODI wine growing region of California. And they are also using the Pesticide Risk Tool or transitioning to use of the Pesticide Risk Tool for their certification program. And so again, it's a whole certification. It's got a whole suite of sustainability, sustainable farming practices that are required as part of it. And then it also addresses pesticide risk directly by taking this approach where they're basically setting a threshold for pesticide risk that growers have to achieve as part of the certification. And prior to this transition, they've been using basically a predecessor to PRT called PEAS to establish that threshold, and are in the process of transitioning to use PRT to calculate that threshold and measure growers' pesticide use basically against that sort of risk threshold. So that's a different way, contrasted with the Eco-Apple program, which basically puts pesticide use restrictions around pesticide use. And that's been the method to lower risk is the pesticide use restrictions. They're sort of taking a different approach where they're saying this is the bar and we're using PRT to measure it. And then growers kind of have to manage their pesticide use during the season with the understanding of like what's going to contribute towards that risk threshold. So that's another approach. Equitable Food Initiative is another program, another certification program that is using the pesticide risk tool, and they're taking yet a different approach. And basically what their program says is that if you are a certified grower, you have to use the pesticide risk tool yourself as a grower, analyze your pesticide use, and then in your IPM plan, talk about how you're mitigating the high risk uses. So that's sort of yet a different approach that puts even more onus back on the growers to say, like, use the tool, understand your risks, and manage your high risks. And then in your IPM plan, which is also a requirement of the program, should talk about how those risks are being mitigated. And that's all of these, or that's a third-party audited program. And so when the auditor visits the farm for certification purposes, they're looking at their IPM plan and they're looking at their pesticide risk tool results. So that's a different strategy. A fourth example is the certification program called Sustainably Grown. This is from SCS Global Services, and they have a different approach to how the pesticide risk tool is being used. And so part of this program is that their growers have to comply with a prohibited pesticide list. However, they can request exceptions to use pesticides on that list. And if they request an exception, they have to run pesticide risk tool for that prohibited pesticide. And then they have to be able to demonstrate that they're mitigating the high risks associated with that. And they also have to be able to demonstrate that there really aren't any lower risk alternatives that are available. So that's a different way that it's been incorporated into a certification program. Deb, to your question, only EcoApple. Deb's asking if these certification programs are described on our website. Only EcoApple, because that's the only one that we are basically operating. The rest of these are other programs that are using the tool, and sort of we have a relationship with them, but I don't think they're described in any detail on our website. They should be, I mean, the use is sort of described in each of their own program materials. So like if you were to download the Equitable Food Initiative standards, you would see the criteria that say like use the pesticide risk tool, have an IPM plan, and then details about what that means for certified growers. So all of it is, public information that can be found. I don't think it's all linked to on our website. But reach out if you want more details on any of this, and I can help track down whatever you're looking for. And the last slide here that we'll talk about, I think, is just benefits and challenges. So benefits of using the tool, it can really help answer the questions like, where do we start? How can I identify what products, what types of products, which growers, what's contributing the most to pesticide related risks in an agricultural setting, whether it's a certification program, a food company supply chain, really any group of growers. Where are the risks? Quantifying risk. So like this puts a quantitative value to pesticide risk for 15 different indices. And because they're quantitative, you can use it to compare across products, across years, across farms, and helping document and communicate risk and risk reduction. We saw the charts and graphs that you're able to generate when you look at for example, the metric of the number of high risks per pesticide application. When you're tracking a consistent metric, you can track it over time, and it can help communicate how risks are being reduced as part of a program. Challenges. data collection. I mean, it does require essentially pesticide application records and them to be in pretty good shape to be able to have enough data to go into the tool to be able to do these types of analyses. For most of the analyses, you need multiple years of data to really get a sense. I mean, weather, climate, pest pressure changes year to year. And so 1 year is really never a perfect representation of risk in a crop or a region. And then challenging to communicate these type of results. In the grower community, it's one thing where growers understand pesticide use and they understand pest management. Trying to communicate this type of thing to the public, I will just leave it at, it's a real challenge. I think I'll end there so that we've got time for questions. There are a couple here. See, Roger, I noticed the EPA was included in the list of contributors. Have we had any feedback on the tool from the EPA?
And some of the data comes from the EPA, but I don't know that we've had direct feedback. That kind of becomes a matter of opinion, whether or not people feel the EPA is doing a good enough job with their risk assessments. The idea behind PRT is that we are trying to really put something together that can get into the hands of a grower and give the most accurate reflection of risk based on actual use patterns. But another thing to consider is we include a lot of endpoints on the data. So, you can look up an active ingredient, in the Ecotox database and come up with, 50 different studies, 1,000 different studies. And so PRT is trying to account for as many of those as possible, where it's possible.
And also just like trying to put risk information in a sort of user-friendly format. So I guess it's basically what you just said here. But I don't think our goal is to compete with the EPA. The EPA says, does it meet some safety threshold and based on a risk benefit analysis? But just because of out of all of the products that the EPA registers, there's still a spectrum of risk. And so the goal is to try to help users understand that spectrum of risk that does exist within EPA registered products. There was another question that had popped up, but I don't see it now.
I typed an answer to that.
Okay.
So we just have a minute or two left here. A couple goals and opportunities we see with the tool here. One is we have, there's a couple of graduate students that got a hold of 30 years of spray records for a grower. And so they're working on a long-term analysis of those records using PRT. And we're very excited to see what those results may look like someday. But we are certainly interested in working with researchers that are interested in publishing research using the PRT tool, and we're happy to work with folks on that. We are certainly looking for more funding to improve and make the tool more robust. And if there are funding opportunities that people want to collaborate on that include research, we're also very interested in that. I think it does seem like, could we someday improve the pollinator indices to account for some of the newer research as it relates to neonicotinoids? We'd love to see that happen, but that takes dollars. And the PRT tool was originally funded by a NRCS Conservation Innovation Grant. So that was the original seed money to get this thing up off the ground.
Again, thanks to our speakers, and we'll see you next time.